Start. వాళ్ళు వస్తారు ఒక 10 minutes అయితే స్టార్ట్ చేసి నువ్వు వెళ్ళమ్మా మడని ఇంట్రడ్యూస్ చేయి. Clearly I am saying I should not hear any sound. Hey, अरे మనుషులు కదా ఒకసారి చెప్తే మేడం పిలిచారని కొంచెం
A very good morning everyone. My name is Sumedha from CS second year. Today we will be having a session with Dr. Amarjyoti ma'am. Dr. Amarjyoti holds a PhD from the University of Hyderabad with academic qualifications from JNTU Hyderabad and has around 14 years of teaching and 5 years of research experience. Her areas of interest include machine learning, deep learning, recommender systems and sentimental analysis. Ma'am, I request you to please come on.
Good morning, one and all. Okay, today I am going to present a topic on supervised learning methods, especially decision tree and Bayesian classification. Now, today my contents are I need to close this session. Close it. Continuous keyboard is there. Please expert in this. Technician should be there. No. PC only. Okay. Sorry for the delay. Now,
Hey, silence.
now today my presentation content are, first of all I'll give introduction about what I am going to deliver the lecture, and the next I'm going to provide what are the different classes of machine learning, and next I'll explain what is the supervised learning and what are the different supervised learning models are existed in the literature. Then I'll explain machine learning process, how the machine learning is going to be processed the given task. Next, I will explain the two methods. One is Bayesian trees, and the next Bayesian classification and Bayesian trees. And later, I will try to introduce different machine learning libraries in a Python. How we can really access the machine learning approaches in the Python programming language. And later on, what are issues we have to face or we have to take consideration while doing the machine learning. So this is what I am going to deliver today's presentation. So first of all, what is actually a machine learning? I think everybody knows it exactly machine learning, but again we will try to identify or try to discuss again what exactly machine learning does. My voice is very loud. Yeah. Here, let us consider the human being. He wants to learn something automatically from the experience which he can learn. So now, that is generally human being does. Whenever we want, we don't know anything about how to interact, how to solve the problems, how can we apply our existing knowledge to solve a particular problem. So, but over a period of time when we are grown up with our parents, we will try to understand how the surroundings are and how the people handle the things. So from that we will learn and apply the same thing for the coming scenarios. Suppose earlier we have seen how our parents treated a particular problem, then we will try to see that and we try to bring it in the next time the same situation occurs, then we try to apply the same methodology to solve it. So this is how we learn from the experience. But how it can be done by the computer animation? So that is actually, if we could able to do the such things by observing the past experiences, and that guides us to solve the problems. Similar way, the machine also can do that. If you could able to give these experiences to the machine, and we try to modulate or model the our experience in such a way that it will act to the problems and resolve the problems the way which was actually solved earlier. So that is what actually machine does. So what we do, we can simply feed the data, and that past data help us to learn the mission. That is called as machine learning. So what we can say in a precise manner is the features of machine learning basically uses the data to detect the various pattern in it. So that means how the past data help us is, suppose as I mentioned earlier, the human being is trying to identify how the previous things are solved. So that means they have some pattern. So that pattern we are going to adopt in our brain and we will try to use the same pattern of the behavior to solve the existing problems. So the similar way it is trying to identify the patterns existing in the past data. So that is the way which we learn
And also, every time we are increasing the experiences, obviously it will learn the new things and it will try to update automatically to improvise the existing knowledge or the existing pattern. So now, and also for that purpose, we need to have a large amount of data so that we can really capture the pattern existing in the past behavior. So this is what actually the machine learning does. So now we will move to the thing. Then how this machine learning can be classified? So how many ways we can do that task? So identifying the pattern. So all of you are might be knowing about these classifications, but once again I will try to brush it up. So what exactly each learning does. The first one is supervised learning. Everybody knows it. It learns from the labeled data. So that means if already the data is labeled and using those labels, we will try to help the unknown data by making the existing labels information. So that we call it as supervised. So now this labeled data act as a supervisor to decide or to identify or predict the given task or given problem. So either it can be classification or it can be prediction of some pattern. So now if you come to the unsupervised learning, we don't have any labeled data. So this experience doesn't know what exactly it means by, but still we can take that data, that experience we could make it as grouping mechanism. So suppose we all have it, we don't know what behavior you had, but based upon your behavior, based on the similarity, suppose the two people are behaving similar, I will make them as a one particular type of the people. But we don't know what type of the people they are. So such type of learning is called as unsupervised learning. We don't know what is the label for that data, but still we have some information about it. That information will help you to group the people. Then anonymously we try to make them as a group, and that's how we will try to learn. Suppose if a new person comes into that group, we will try to see this behavior of the new person is matching to the which group. Then I will make that new person as a particular group. But we don't know what label it is or what is the name of the particular group. Such type of learning we call it as unsupervised learning. And another type is also there, that is semi-supervised learning. The semi-supervised learning is basically we don't have little labels for the given past experiences, and past experiences. However, most of the data doesn't have any labels. So at the time, with the help of this small amount of labeled data, we will try to predict the unlabeled data. So by mixing of some of the labeled information and most of the unlabeled information, our experiences use it to solve the given problem. So such type of learning is called as semi-supervised learning. So now the last type of classification of machine learning is reinforcement learning. In this reinforcement learning, we don't have a data, we can say that, and maybe that data is not sufficient for the problem solving. Let us, I want to close my eyes. I want to travel from this place to the end of that room, but I don't know how to go in, how to move it from here to there. I will go just by trial and error method. I will move left or right side, and if it is no hurdle scheme, then I will move. And still if that's slightly going to the left and door stops me, then I will stop. I will conclude that this path is not that path to the back side of my car. So likewise, I will try and error. I remember what is a good one and what is a bad one in terms of penalty, and bad one will take it as a penalty, and a good mark is as a profit. By using this strategy, finally I will reach to the solution. Likewise, you trial and error method, you will try to solve a given problem. Then such type of problems are such type of machine learning are called as reinforcement learning. This nowadays, this is moving up. So because most of the problems are still not solved, right? So using this reinforcement learning, we can able to solve this problem efficiently. gave a glance about what exactly supervised learning. Now we will see how this supervised learning help us to solve the given task or to solve the problem. Now let us consider there are labeled data. So here we know every thing as a label. Now if it is a rectangle, we know the label of that shape is rectangle, and similarly circle, triangle and so on. This small data will be given to the mission, and we try to identify the patterns, and the patterns were modeled in the search of ML model, and we will going to be finding all this labeled data on the model. Now I will take a new data. It might be any one of these existing one, and I will test on that model that really it is trying to identify the shape of the object. So then if it is able to predict the triangle as a triangle or circle as a circle, then I will say that my model is good model or fit enough. So what I am trying to say in this one is, if you have the labeled data and use that labeled data to train your machine learning model, so that makes to predict the unknown data in a real world scenario, such type of learning we call it as a supervised learning. Then you may ask that how it is possible. Yeah, it is possible in the mathematics. So that model is, suppose let us assume I have a linear equation. Suppose I know x and y values. If I know the x value is f of x is equal to y, then what is the x actually function? If you could able to find it, I can able to predict the y. Yes or no? So my problem is here is, what is this function which fits all my x values to the y values? So that is what we call it as supervised learning. Maybe it is a simpler form of it, but the thing is the same. So if I know, if I could able to find this f of x where all the given x values are predicted without error as a y, and that is actually called as model fitting or finding the objective functions for the machine learning model. Now using maybe already some existing models are there. According to our problems, we will try to select one model and we solve the problems as a machine learning model. So now this is how a supervised learning works. Because we know what is the x value for the given x, what is the output value also we know. That is output label itself, or output value itself we call it as a label. Now whatever x I am talking about, those are the input values for the given output. This type of information we are feeding to the model or mission. Such type of learning is basically called as supervised learning. I hope everybody understood it, how we are, what actually in the supervised machine learning is. Now, the supervised learning also can be done in two different ways. Either we can be considered as a classification and we can be considered as a regression. So what exactly classification is? Suppose you are having the boys and girls. I know what are the appearance of the girls and appearance of the boys. So now if I knew these two persons came into my class, now I should be able to find out whether the given persons were actually boy or girl. Now such type of thing we call it as classification. Okay. Now either it is one label, predefined label is there for the given values. So such type of thing we call it as classification. Then what is meant by regression? There won't be any labels for it. Suppose I know the, as I mentioned earlier, I know the x value and I want to predict the y value. That y value always need not to be in the form of label. It is not predefined. I want to know what is the approximate value for that y. Getting my point or no? So this is not a predefined one. Suppose y is 2, let us assume. So x is some one. For x, one value, I want to find out y value as 2. For the given function, I may not always give either an exact value because the labels were not any fixed number. The given x, there are different values is there, and the given y, there are more possible number of values will be there. But I want to find out x value for the 1 as a 2, then I may not to identify 2. It may be 1.9 or 1.8. Likewise, I will try to predict what is the value for the given x. Such type of prediction is called as regression. So those were not labels actually. These are continuous values. We are trying to predict it based upon the given x. Such type of machine learning is called as regression. So now these two things we are going to be learning in this session in the form of relation tree as well as machine learning. How these are going to be performed with both classification and regression. Bayesian is somewhat different, but especially when we talk about the relation tree, probably we have different types of trees which will do both classification as well as the regression. I hope everybody understood what exactly meant by the classification and regression. Now, what are the different examples for this one? You can say that classification is basically a relation tree, k-nearest neighbors algorithm, base, naming base, etc. These are the problems for classification. And the regression for is like a linear regression. So this is one popular algorithm in a regression type of supervised learning. Now, how exactly the data look like in the both classification and regression we see in this example. Let us consider this is one type of table, two tables were seen here. The first left side is a classification table and the right side is a regression. So here if you see the gender is male and salary is something and age is also described. Now I want to see whether the given person is going to purchase the product or not. It is in two classification. The labels are two only. Either you can purchase or not, yes or no. Then the yes or no is going to be represented as a zeros or 1. So here only it is two labels. I need to predict for the given x value. These are all features I can say. Remember these terms. So whatever this table is there, this table consisting of how many attributes? 5 attributes. Among these 4 attributes are the features. Maybe those features helpful for us to decide the output or not, that is different story. But I have the 4 features and one label that we got one feature, one attribute is output attribute or output label. This is the target variable, not target attribute, or target feature. I could say that for the given these x values, I need to find out the f of x in such a way that I could decide whether the given person is going to purchase that particular product or not, either in the label S form or in the label no form. This is an example for the classification. So if you see the same, the right side of the thing, so it has a temperature, pressure, relative humidity and same section is there. Using this data, I am trying to predict what would be the wind speed. Now there will be no fixed label here. I need to predict that value as a continuous value. So such type of things we call it as a regression. So now you see that this is my target label. So but that is not a label, but it is a value. Such type of thing we call it as a regression. I hope everybody is following. Is it understandable? Is it easy? Yeah. You have any doubts, please stop me. I will try to give more clarity on this. This will help you for your own projects, in your major projects. Yeah, how it does actually. We know that what is the input values, input features, and what should be the output label in a different types of classification. Then how this is going to be happen for a given x variables to the y label. So this is basically called as machine learning process. First of all, we define our problem. What actually the problem we want to solve? Whether it's a classification problem or regression problem or which. So in the classification problem, what you want to find, what you want to solve. First of all, you should be very clear with what you want to achieve with the. So that is first of all we call it as define the problem. Then build the data set. So if I want to find out whether the given person is a man or woman, data for this process, I should choose the correct data set as the human beings only. Suppose in the same case, in the earlier another data is also there, temperature data. If I use such data to decide my gender, can I be able to use the data set for problem solving? No. I need to select the appropriate data set to solve the given problem. So that's why we need to build the data set first, which is very relevant to my problem. So it is authenticate and reliable to solve the problem. Otherwise, the data is not correct. Obviously, your solution is not, even though it is showing it as more accurate, but real world problem solving it won't work. So that is selecting the appropriate data set and preparing the data set is actually building the data set. Whatever the data you got, you cannot apply directly onto the machine learning. Probably you might have learned different subjects like pre-processing of the data. You remove the unnecessary data and serial numbers not required, I will remove it. Some null values will be there, I will remove it. Likewise, I clean my data and make it ready for the applying the machine learning. So that is the second step. Then I will apply training. So what is meant by training? So I simply can I use both give me the
One side you can use it as a board.
let me check. Let us consider f of x is there. And I am doing ax plus b. Not this example. Now, I am trying to apply the given x value. Return matrix for x is equal to 5 and y is equal to 10. Let us assume. Now, I want to apply this equation. My f of x is equal to x plus b. Now, I need to find out what are the a and b value in such a way that whatever x I have given, that should be the correct way. Getting my point or not? Now, I will apply x here. Suppose if I say 2 into 5 plus 0 is equal to 10. That means my what is the a value which I got? 2 be equal to 2. Okay. Now it actually doesn't give me anything. See, now I will take one more sample. My x is equal to 5 and y equal to 7. Will is going to be applicable a and b values are fixed now? No. I should fix this a and b value in such a way that for a given x, I should produce the 10 value, and also for the given x, I should provide the y value as a 7. So in such a way that I should match my a b values. I need to learn what a b values I will produce for a given x value, the correct y value. Now, for that purpose, I need to take the more data in such a way that I should be able to fix this a and b. It will be applicable for the all such similar patterns data. Yes, come in. So now, I have 100 samples here.
Please don't make noise.
Yeah. Please attention here. This maybe you feel that is a minute, but it help you to understand the philosophy of machine learning. Please try to understand it. So if I have 100 samples like this, such a way that for these 100 samples, for the given x value, you should provide the correct y value. So, to identify what is the correct coefficient for these 100 samples, for the given x is correctly predict the y value is called as a trend. We will find the more data and such a data. You will find these coefficients which can fit all my x into the y. Okay. Now, for the if I take the two values, will it be able to find the third value correctly? No. With this less data is not sufficient to identify the pattern of the given data. For that purpose, we need a large amount of data. In such a data, we could able to predict this AB coefficient that will help you to decide the same pattern x value can give the correct y value. Getting my point or not? So this process is called as training. Once the training is over, then we will check whether it is correctly given the output or not, or correctly classifying the problem or correctly solving the problem or not. Then you may say that, how can you evaluate it? Now using the different methods we will evaluate whether the predicted value is correct or not. Let us consider I have told you that I am going to predict the y value. Now in these 100 samples I have corrected 90% of the x values are predicted correctly as a correct y, and the remaining percentage is not predicted that y value correctly. Then how much percentage of accuracy I have in my algorithm? Pardon? How much percentage of values predicted correctly? You are not listening to me. I mentioned that 80% of the x values are predicted as a y correctly, and the remaining are not predicted correctly. Then what is the percentage of accuracy or percentage of samples predicted correctly? 80%. So then I will see that whether how much was really correctly predicted by using this training. That is how we will evaluate our model. And in case the regression it is not correct prediction or not, because it is a continuous values, then we will take the error. Suppose if 9.5 is taken, 9.5 as the value is predicted, then actual value is 10. What is the error now? 0.5 is error for the one sample. Likewise, we will average all these error, and the error should be less to say that my model is working correctly for the regression. So this is how I will evaluate my model whether it is currently actually trained or not. Once it is well, suppose generally 70% above accuracy is giving, we will think that that is actually good enough to train our model. Then use that model in a real world scenario to test the unknown samples which are not from the trained data. So this is how the machine learning process is. So for that purpose, to evaluate this model, we will split the data set into two parts. One is training data set, another one is testing data set. The training data set is helpful to train your model to fit that objective function in such a way that all the possible given x's are mapped to the y correctly. And this test data set is helpful to really check the unknown or not trained samples were really predicting correctly or not, or classifying the labels correctly or not. That is used for the evaluation of model. So this is how we need to split the data set to check whether my model is working properly or not. So this is what we call it as machine learning process. Now we directly come to the decision trees. Now as I mentioned earlier, the supervised learning, there are different types of supervised learning we will take. One is classification, another one is regression. Now one of the popular easy to understand the machine learning is a decision tree. So what is this decision tree? So now this decision tree helps us to make the decisions by making out the different choices and their possible outcomes. So using this approach, we will try to classify the given problem. Then how it is possible? So you can see that same thing in the given tree. And before going to how it does all the things, I would like to tell that there are two different types of the machine learning algorithms we use. One is parametric machine learning and another one is non-parametric machine learning. The parametric machine learning means that you will assume that the given data is in some distribution. It can be a natural distribution like Gaussian distribution. So we assume that and use those things to predict your data. So that assumptions will help us to identify what are the parameters I need to fix into my model. Okay, such type of algorithms are called as parametric algorithms or parametric models. And one more thing is non-parametric. In the non-parametric, we won't assume about anything of data. No distributions, nothing. We don't have any assumptions about the data. Simply we take the data and we will try to see the features of the data and the target labels, and we try to come up with one solution in such a way that they will be classified properly and model the things properly. Such type of algorithms or models is called as non-parametric. So in this patiently is a non-parametric model which doesn't assume about anything of, it doesn't assume about a data set. Or it is not in any distribution or no assumptions in it. Simply it will take the data and process based upon the features and the target label. Okay, now how it does, how basically the decision tree looks like. If you see in this diagram, you can see the root node and there will be different data node and there is a different branches from the root node and also there are a leaf node. Now, this basically root node is the starting point for my decision tree where we will consider the all data sets. All holistic data we will consider. We won't split anything, simply whatever the data in our hand, that will be considered the root node. From that, we try to make a decisions based upon something obeying or whether it is some rule we will apply, and we will try to split those entirely into different branches. If one type of the decision it is satisfying, I will move to one part. If another type of the decision is satisfying, we will move to the another part. In this way, in the multi-level way, we will try to segregate my entire data into a tree. Finally, the target label, whatever we are to predict that will be in the leaf node. So once you give this data to the root node, by taking the attribute values, one by one, you place it out from the root node to the leaf node, and we will decide whether the given sample is classified what. The what it is actually going to be decided by this leaf node. This type of machine learning is called as a decision tree. So how really it does, what are the things we need to be considered, what are the attributes, how we will solve it, that we will be going to see step by step by taking examples also, don't worry. But the thing is, it is a tree and the root node, we start from the root node where we will consider the entire data set and we will take the decisions, and by branching that data set into internal nodes, and these internal nodes are going to be processed until we reach to the target label. This is a decision tree. So now, then this decision tree also can be used in two versions as I mentioned earlier. It can be classification tree or it can be prediction tree. I think all of you know classification or prediction. Classification means
Phone
the
local.
output labels are defined and known to earlier, and the prediction means it is a regression. We will try to predict the value, continuous values. So there is no confusion at all. So the classification is we know the labels in your hand, we know the labels, but in the regression we will predict the values. It can be continuous or different, whatever it is. So now in the classification trees, we use the or we try to predict the categorical outcomes. Because we know already what category it is or what label it is. So, like suppose if I want to find out whether the Indian mail is a scam or not, because we know the label before. Such problems are going to be solved by the classification trees. And here, anyway, example for this one is ID3 and the C4.5. These are the popular example for the regression. So now, if I come to the regression trees, it predicts the continuous values as I mentioned earlier. Predicting the house prices. So here instead of categorizing or giving the identifying the label, it's trying to predict the value which is continuous. So such type of called as regression trees. One of popular regression trees is that is classification and the regression trees. So in this presentation, I am trying to explain how this ID3 works and also how this works for solving the different. So now we move to the next one. Classification trees. What is the process of classification tree? So first one, we start with the root node. So we will start with root node as I mentioned earlier. That is, because the main question at root node, which actually derives from the entire data set. So what question you are going to pose will be at the top. Now, based on that question, you will try to apply the rule in such a way that what type of answer it is giving. It is it. If you pose any question, if the answer is yes, we will move to one particular branch. If it is no, we move to the another particular branch. Likewise, we will based on the questions, we subset your entire data into two parts. One part is one side, another part is another side. So the branches, based on the answers, the branches will be going to say yes is one part and no is will go into the another part. Then this process is continuous until we reach to the final label. Okay. Now this is when we reach to the final label means it is a leaf node. So the leaf nodes really tells us whether this one is yes or no label. Let us assume. So now we will see exactly, maybe by seeing this theoretical part we may not able to get idea, but I will really take one example how the decision tree will look like to solve the classification problem. Yeah. Now you see this one. Is it visible? Yeah. So let us assume, consider this particular one. 4, 5, 6. Among these 5 attributes, one is target variable, that is play tendency. This is my target attribute. These are my features. Okay, among this one, I feel that day is my not actually important thing. Important things which actually have meaning is these 4: outlook, temperature, humidity, wind. So, in this, based on these all data sets, I have constructed my training in such a way that it will be classifying all these things as no. I already processed it. This, how you do this one, we will see in the next example. But let us assume I have constructed my tree from this training data. Now let us consider one sample that sunny, hot, high, weak, and weak. I don't know. I will mask this label. I need to predict by applying the same sample to my decision tree how it is going to be classified. Last bench, second person, please stand up. You only. Last bench, first person. Last, second bench, first person. You only. Now. Yeah. Listen to me. I'll ask question to you. So, this is, I am just masking to see that how the decision tree works. So now, I will take this thing and apply under my decision tree outlook. Okay? This, what is my outlook? Sunny. Then among this one I will choose which part is the sunny. First part. So I branch my data set to here. I will move to here. Sunny. The sunny, again, I will check that humidity. What is the humidity which is there in that? High. So where I will move from here to this one. Now my label is no. Even I didn't check the temperature or wind. Automatically I could able to predict no. Is it really no? Yes, you already seen. I have told you to note down in your paper. Okay, now this is how we will try to apply the samples which are not observed or trained in the given model, and we will see how actually we try to predict using the decision tree. Then question is that, ma'am, how you have constructed this tree? This is how you check whether the given sample is classified into S or no. But we need to understand how it is going to be solved. How to construct this tree is more important than simply applying it. As a software engineer, you have to build your own model so that it will be able to take your input data and predict whether which class it is, yes or no. So now the question is how to construct this tree. Now, I will move close here.
PC means you will get the desktop. You are using board. No, by board or by
No, I'm using PC.
PC PPT. Go back.
Wait, wait. Pillow number, ever coordinate Sir, it is giving trouble every time. Again, it is stopped.
Sir, here. Click on desktop. Here, corner. Desktop. In download the data. Without eyes.
Please silence.
Yeah. This is how we are going to split the given
trees. So what is the last sample in classification label? Yeah. I make you stand to tell the answer now. Just now I gave answer. You just again repeat it again. What is the previous sample class label? What you are listening there? I told you to listen and answer now. Please just be patient and be attentive to the class. Sit. So now, yeah. Yeah. See, I have no, the entire data is going to be considered the root node. Then how I will split these data sets into left side or right side as we have seen in the previous tree. So thus is going to be happened with help of the two different approaches. By using the Gini impurity and using the entropy. These are the two approaches will be used to split your relation tree into different branches. The first one how you decide is, now you create, you will use this Gini approach and you will try to find out how much impure a given feature is. Okay? If impurity means it is more value, then it is more impure, and it is less value, it is less impure. That you always choose the less values to make it as a root node in such a way that we can preserve the pattern of the data and we can split the data into subparts or subsets. So based on that, we will decide which features should we keep at the root node.
Ma'am, should I ask a
Yeah.
You mentioned different categories, either video or data, video, audio, any data. Have you asked?
This doesn't handle the.
Means we can't get the means pure data. Pure data means how we can.
No, the impurity doesn't give the value impurity or value purity.
So
It is actually talks about which feature is fit enough to make the decision of a given data.
I mean the data consists of so many variations. Na? Either maybe audio or video or text data.
The decision tree doesn't work on audio video. You have to go to the deep learning.
Text data.
That is the disadvantage of decision tree. So we cannot make all the decisions simply by taking the audio video. This is not quick enough. We have to go for the artificial neural networks. In that also, convolutional neural networks will be there. There we will try to take the entire video audio data as a grid, and the grid is going to be fed to the hidden layers that will process. Finally, we will be able to predict.
Decision tree is a machine learning or is a deep learning?
Machine learning only.
Machine learning is related to ANN, no?
Ma'am, in the machine learning there will be two parts, without ANN, with ANN. So this is without ANN. So if you go, the complexity of the problem is increases. This is a traditional machine learning won't fit. Getting my point? And one more thing, this relation is only try to label it as a normal, what we say, discrete values.
Which is related to the labeled data.
Labeled data. And even video audio also may be labeled, but the data is not in a discrete manner. It is a continuous or it is individual data in a matrix. Such data cannot be handled by the distribution. Yeah. Madam asked me a wonderful question. You should get that question actually.
That is really useful for you guys.
Yeah. Now thing is, this Gini impurity tries to help you to split the which feature we should get in the left side and which feature should be in the right side. Okay, tree means it is a branches only. So which branch a particular feature will hold. That will be decided by this image. Similarly, another thing is also there that we call it as entropy. Entropy is trying to find out how much information gain you have in a feature. That will help you to decide which feature has to be kept in a one particular place, which feature should be act as an internal node. So this value should be high. The gain is high means we will make that as a more prominent feature to keep it at the top level of the tree. So these are the two types of approaches will help you to decide which one is the root node, which one is the next level node, and which we will, how we will split the tree into different branches to reach to the leaf node as the label is SR node. Any questions regarding this? The next question is how this is going to be applied for the given data which I have mentioned earlier. So now let me show you. This is the data. I have, as I mentioned, my features are this one, outlook, temperature, humidity, wind. These are my features. Feature 1, feature 2, feature 3 and feature 4, and this is my target attribute. As I mentioned. You remember this one. Based on this data, I am trying to find out which one is the root node. First of all, I have to decide among these features which one I should pick it as a root node in such a way that node will decide for a given sample it will classify it as SR node. Okay, so first choice of root node is very crucial. So for that, I will try to find out what is Gini value of the each attributes or each features in my given data set. Got the point? Now that I will show you the process slide.
Yes.
Right, business. WhatsApp
Now my target is plate tennis I have already shown you. Now how many S are there? 9 number of S samples are there. Please listen carefully. This will help you really in the third year. So, and no number of samples are 5. That means my target label in the given entire 14 samples, 9 are S, 5 are no. So now I will try to find out the Gini computing. So here how many classes are there? 2 classes are there. So my Gini will be 1 minus sum of all the probabilities of the given classes. That is equal to the probability of S is equal to 9 by 14, probability of no is equal to 5 by 14. So now I will find out the root of this one as 1 minus 9 by 14 square and so on. Finally, I will get the value, Gini value as 0.459. This is the root value, root Gini value. So now, I will try to find out what could be the further individual features. So that I will show you.
Here any threshold value had to maintain?
No ma'am, this is the root value. Which one is the smaller, we have to consider it. There won't be any
Threshold,
threshold.
any threshold value?
No, if it is there, that should imply in the equation itself. Yeah. Now, I will take outlook. First of all, I will take the outlook feature. Please, if you are, at least if you are trying to understand the essence of the thing, it is fine. The calculations anyway you will find it in the Google or somewhere. But you try to find out why this is going to be computing. So please try to listen to me. If you are having any problem with me, you are always welcome to question me. So now, first of all, outlook is there. In that I have a different values for the outlook. One is sunny, overcast, rain. These are the three possible values for the outlook. Okay, now I will compute each attribute value for a given feature. So first of all, I will find out the sunny. For the given table, the outlook value is sunny. That how many are there? Total 5 number of samples, which actually gives the value as a sunny. Those total number of sunny attributes are there in the given data set, that is 5. Among these 5, 2 are leading to S variable and 3 are leading to no variable. Now I will find out the Gini for the same procedure what I have applied for the sunny, root value. Likewise, I will compute for the sunny, I will compute for the overcast, and I will compute for the rain. Finally, I will try to find out what is entire outlook, Gini for the outlook attribute. That is 0.43. Now I will move to the next slide. Now, the Gini is 0.45. Actually, this is a root Gini which we have computed in the first step. Minus, what is the value which I got for the outlook? 3.43, that is equal to 0.16. This is my impurity value of the outlook. Likewise, we have to find out for the every feature's Gini value. Outlook, outlook, temperature, wind, humidity. For this all simple same approach we will apply and we will find out the Gini. Among these 4 attributes, which one will give the less Gini? That will be the root one. Okay? Remaining how many left? Already is over. Outlook is over. How many left? Remaining 4 are left. Now we will try to consider those 4 samples features and try to find out the again Gini value. Likewise, we split the tree into SR value. In such a way, we could able to find. In between, maybe you may reach to the final. If all the, for example, one branch, there is no splitting at all. Let us assume, I will go back to my one. Back. See, after coming to here, all the samples of this criteria only having either yes or no. There is no clash between the samples. That means no need to split again. Because already all the samples are probabilistically deciding whether it is yes or no. There is, for example, 5 samples were came here. The 5 are no, then no need of applying any branch. Getting my point out? Now likewise, we will try to split our features and construct the tree in such a way that the internodes will have the next lowest Gini and so on, so that it will try to identify the target label. This is how decision tree works for classification using the Gini. Now the next method is entropy. So entropy is something different than this one. There the entropy should be more. That means information gain should be more. That means whatever the feature actually store the maximum information about the data. That is the possible patterns of the data basically depends on that particular feature is called as information gain. So that is going to be learned through the next problem. The same problem I will consider using the entropy. So the data is the same and the target range is the same and the samples are also same. But here, first of all, we will try to find out which one is the root node. The same here, we will compute the entropy by using the formulas. So the property is also here, we will probability of each class. So likewise, you will find out that entropy of the root node is 0.940. Now, the entropy for the each attribute we have to find out. Similarly, for the sunny it is 0.71 and overcast is 0 and rain is 0.971. Now I will try to find out the weighted entropy of all this outlook, that is 0.694. So the information gain would be the actual gain of the root node minus the weighted of the output. Now this is 0.24. Likewise, I will try to find out entropy for the temperature. These are the entropies. And humidity. I don't want to explain, these are the theoretical. We need to understand the procedure. See now, you see that the outlook, humidity, wind and temperature, like everything we have computed. Among this one, this outlook has the more information gain or more entropy that help you to decide that would be the root node of the given. So then based upon the root node, again we will split that one by using the attribute values, sunny attributes values, overcast and wind. Wind enough? Rain, yes. Split that samples again, then you will get the subset of data sets. Again use the same. Now we won't use the original data set. After splitting it, whatever the table you will get, that table you will apply in the same approach and you will decide which one is the next root for the subnode. Likewise, you will going to be continue until in a given branch and a given leaf, all samples are either yes or all samples are no. So there is no clash between yes or no, there is no need of splitting. This is how we will use the entropy to splitting the Bayesian tree and finding the root node and subnodes, so that we can decide a given sample is actually giving the S value or no value for the latency. So this is how the decision tree works. Okay. Now, till now we have seen the decision tree for the SR node type. How this regression will work, how the regression is going to be computed using the decision tree, that also you should understand. So now we move to the next part. Regression tree for predicting the continuous values. Till now SR no only, there is no. But here the thing is, how you will try to identify the value, how you will compute the y value as in the form of continuous values. So that is going to be learned in this one. So for that one, we generally follow the error measures. So these error measures really tell us what is the minimum error I could get from splitting the data sets in a proper way. So my target is that I should split my data into sub-branches in such a way that the error between the target values and actual values should be less. My target is minimize the error. As I mentioned earlier, suppose I want to predict the 10, then actual value is a 10, I have predicted it as a 9, then what is error? 1 is error. So this 1 error should be less or more, we will decide based upon the entire data set. So our intention is that we will try to minimize this error in such a way that we have to split the data. So how you do that? So to measure these errors also, there are different types of approaches are there. One is
Complete close.
Yeah. See, this is mean square error and mean absolute error. They are the different error mechanisms. There is some difference between these two things, but I don't want to make you get bored of going in depth into that. If you really want to know, then I'll try to reveal why we need to use the two different errors and what is the purpose of individual. But as of now, I can say that this MSc is one, and mean square error is one type of error metric, and another that is absolute. In that, errors are squared and then we are going to be normalized by n, but they are not going to be squared. So, but there is a basic logic in that why you will scale it. If you know the mathematics, probably you know it. I won't reveal it now. If really somebody asks me to explain, then I will explain later. But let me complete this relationship. So now the thing is, how these measures will help you to split my tree into branches. Yeah, let us consider here. The previous data doesn't work because the previous data is only meant for saying yes or no. But here my question is that what is the value which I need to predict? Now let us say that is x is certain values are there and the house price in the last some values there. Now I need to find out a tree in such a way that if I give a exercise, then you should be able to predict the house price. Now, this is generally going to be sorted order because we need to have a midpoint to check whether given predicted value is correct or not. Generally, the idea behind is that always we will try to predict the average value. So, why we do the average? Suppose if I say what is the class percentage, then we will say that average value. That is actually decided as a common thing in your class. That will help you. Suppose if I want to pick somebody's percentage, if I pick the average, then probably the less error will be getting to predict what your percentage is. That is the actually benefit of average. Probably every day we will use it, but we don't know the meaning of average here. But it is very much helpful in the machine learning. If you want to find out the continuous values, the best metric is the average. Suppose everybody's average, if I took the average and I predicted the 10 people, compared to any other cases, the average guess will be is the less error. So that's why we will first of all try to find out what would be my average thing. It is sensing very fast. So first of all, I take these values. This is my average value of all the given x. Now I try to subtract the each value by this average. Okay. Now the root error will be 114. That is the error which I can get in the worst case if I pick the average value. Now I need to find out what if I split. I take the random split. I have 1, 2, 3, 5 data sets. Initially I will take the middle split. So I will take only the 700 less than values are the one side and the 700 greater than or equal to values are the right side. Likewise I split and will check that how much average error I am getting. So in that way I will see 30, 35, 45. Now this is my expectation is 36.7. Now that is going to be again remove the average from the actual values and my error is 38.9. And similarly I will find out now this one is this. Now I remember this information so that I will try to know what to split in. Now I will apply this after split how much are my values. So now I will apply this to 3 by 5 into 38.9 and 2 by 5 into 25. That means the percentage of the split which I have made. Now my value is 33.7. Now what is the variance of originally predicted value minus the splitting value? Now likewise 80.7 is my original quality of for the given split. Okay. So likewise I will try to see, not only this, you can take any number of splits. Whichever having the less error, I will choose that node is a big reduction. Means here 1442 it came to the 8.7. That means that this reduction means it is not error. Actually, reducted error. Originally, what I have got 113 I have predicted. This is error of my original data. But after splitting, how much I received the error? 33.3 only. That means the reduction is much more. Likewise, for all the possible splits, I will find out. Then which split is giving the maximum variance reduction? That split I will consider as a 3 split. Now here, let us assume obviously this will be the good split because it is only 5 possible values are there. It is easy to decide. So no need to do every possible split. Now for this one, now I will take entire side as the root node here. The next predict one is 36.5 and next predict the right side is 55. Likewise I do. So this is how the regression trees are constructed. You found any difficulty in this problem? Anybody can sense it? The thing is, ratios are very easy to understand and they intersect why this particular node is came into the root node, why the siblings were like this, how the root leaf node were. This is intersectability is very much clear. We can easily understand why and how it was constructed that tree, and the justification is very easy and easy to understand. But the thing is, first of all we talk about the positives, then I will go to the negatives. No data scaling is required. Have you performed any normalization or processing for it? No. Simply we have considered the original thing and as these we have taken into the account to construct the trees. Then it can be handled both categorical and numerical features. That means both we have seen classification problem and as well as the regression problem. So it can handle the both type of variables. It is maybe in a SR type values and a descriptive values, or can be numerical values in a continuous prediction of some numbers. So and it can be very fast once the tree is constructed, because we have seen that we will apply the one by one, we will go to the left node, the remaining we will remove. We will back to again the node and we will decide SR. That we have seen for the sample introductory part of the relation tree. That applying the input sample and predicting the value will be very easy and very fast. But the problem with this is overfitting. What is overfitting? Anybody can tell me? You have any idea about overfitting? Probably you might have listening to the so many sessions now, till now. Huh? Anybody, just remember it is wrong, it is fine, but try to tell me what is overfitting. Chakka?
More bias.
Yeah. You cannot say bias is also one reason for overfitting, but the thing is, we are very much trying 100% in a given value data, but the behavior of the original data may be different. That means that when you are evaluating when you are trying it, you are 100% accurate. But if you really applying the sample for the testing it, that fails. That means you are overly fitted that entire training data to fix the subjective function. But it really not works for the real world problems. The behavior is very less. This is a big topic, but here I would say that, as he mentioned, the biasness is one reason. Certain classes are really very good at, and certain classes are not having in your data set, that the features may not be able to capture it. Because of that, it may not really going to reduce. The simple terms I will tell. I know that all S classes are 80%, no classes are 20%. Then using these S classes, I could able to identify the behavior of the S samples. But because of it is 20%, I could not able to sense it as a no class. The behavior of the no classes I cannot able to capture. What happens if the given sample is S, obviously 100% I will get the answer. If I give the no sample, it will be treated as S only because it is overly trained than S sample. It cannot able to capture it doesn't work and it won't give the correct prediction. Such thing we call it as overfitting. That is one problem in the relation tree because we are very fixed strictly depending on the splitting and using the linear or entropy. You were very much strict to the classes. If the data set is not properly distributed among all the classes, this problem will occur for the relation tree. So next one is unstable model. Suppose one small change occurred. Suppose my timing samples I have added 10 more samples. Again I need to construct entire tree. Yes or no? Yes or no? Because the distribution of different labels got changed, so again I have to compute from the starting of the tree. So that's why the relation tree is not stable for the event data. Every time you included the more samples to try, it has to modify the tree's behavior. So this is another problem. And the thing is, for the small example, we have to do these many steps to construct the relation tree. If the large data is there, then how can you construct, how complex the construction of tree is, you can imagine. That is the drawback of relation trees. For the given 14 samples, we have gone through only we could able to work on the outlook only. We have not solved other features. Likewise, if the more number of features are there, more number of samples are there, the depth of the tree will be increased and it is more complex too. So this is the drawback of the. It is easy to implement and it is easy to predict the values fastly once the tree is constructed, and there is no need of scaling or much knowledge about how to scale your data and process your data. At the time, the relation tree is easy to implement and it is comfortable to classify or predict the continuous values. This is all about the relation trees. Now I will move to Bayesian classification. What is time now, sir?
11.
Okay, I will try to finish it. This is not how much me. So already everybody knows the probability equivalent. So the Bayesian tree is basically probabilistic approach. It's a classification based on the Bayes theorem. So the Bayes theorem is a conditional probability, everybody knows it. Based on the conditional probability, we try to pick whether the given sample is yes or no. So how it is going to be series? As I mentioned earlier, this is a parametric model. The parametric model means it is going to be dependent upon some distribution of the data or the assumptions it will made on the data. So now the theorem anyway I need to recall, but anyway these are the things which I need to say. What is actually equations for this Bayes theorem. Now I will move to the how it is going to be solved. It is basically how much likelihood is there in that particular sample and the data and the prior information, that is what is the previous probability of occurrences of that table is also going to be considered and applied. Then we will try to find out the posterior distribution and predict the class value. Now how it does actually. So these are the samples. The message, there are two features are there and the classes are spam or not spam. And here we try to find out the prior probability, that is what is the probability of spam and what is the probability of not spam. Then we will try to find out the likelihood. What to say? How many samples for spam, which is saying alpha is equal to S. Likewise, 2 by 3 into 1 by 2 is for the classes. It is 2 classes are there. So that's why 1 by 2 is going to be added. That is 3 by 5. Similarly, what is the class value for the span in the case of 3 is equal to S. So that is 2 by 3. 2 by 3 into 1 by 3, 1 by 3 equal to 3 by 5. Likewise, for the non span also we will try to find out the likelihood, that is the conditional probability we try to find out. So then we will try to find out what would be the class for the offer is S and the free is S. If I take the sample that offer value is S and the free value is S, then what is the class label, whether it is a spam or not spam, then we will try to find out this likelihood. This is the probability, prior probability of the possibility of X or the spam, and this is the likelihood of the given one. Then we will got the value 0.216. For the not spam, sorry, for the not spam, probability is 2 by 5 and the likelihood is 1 by 4 into 1 by 4 for the different yes or no possibilities, and the probability for this not spam is 0.05. Among this one, which one is the highest probability? For the spam classes have the highest probability, then we predict the class as spam. This is how a Bayes theorem is going to be applied to decide whether the class level is yes or no. So, but thing is, what are the pros and cons for this particular one? Yeah. It handles the small data well. So, if the data is less than finding the probabilities and the failure probabilities, and it can also incorporate the domain knowledge easily into the data. So we can also visit the properties. So output tuning is also helpful here, and it is takes non-linear relation boundaries. I think these are all the pieces which are had for the Bayes theorem. But the thing is, if the high dimensional data is there, this may fail. So you may not be able to produce accurate results. And for this large data, for the estimation of time distribution is very difficult to handle. So these are the disadvantages of Bayes theorem. So if it is a small data, it works well and it is easy to handle. But real world problems with a large data like complex data structures it has and non-linearity is more in that data, probably it may not be sufficient. So obviously we go for the other suitable classical models. Now these two things we have learned are very interesting, but thing is that how can we integrate these in a programming way? So all of you know that machine learning approaches can be comfortably implemented in the Python. So in the Python, what are the things which we need to know or help you to solve this machine learning problem? First of all, we need to have these are the prerequisite packages in your Python software like Pandas, NumPy, Matplotlib, and you don't have real data sets in your hand and you want to practice the models on your board, then you simply import the existing data sets from the statement. So that is, you simply scientific toolkit run SQL means. So using this one, you can import the data sets and you can apply the algorithms and see how they are working as a practice. So for the different algorithms, you can use these header files or library functions so that we can simply import those values and use those functions to see how your models are working and how they evaluate and how to fit the model, how to see the data, and all these things we can learn from using these things. So these are the certain things like import tree for the decision tree and import logistic regression for the logistic regression model. Likewise, so based upon your model, you simply go to this website, you will understand what are the different algorithms available either for the classification, clustering or reinforcement learning, what are the different packages you need to import and how to do that. Sample programs will also be available in this website. They will help you to how to model your machine learning, how to evaluate it and all. So this model selection also is there, that means how to evaluate. Simply checking all the errors or maybe accuracy of the thing. Not need to write the code from the scratch. It is already available in this one, like text and file text split. This will actually divide your data into training and testing parts. And you can also use the class validation. And using this matrix, we can compute either accuracy or mean square error or mean absolute error. Likewise, all these metrics can be utilized using this one. Now, some of the things which we need to carry while to finish this particular one. So, always machine learning works in the way like the better data often beats the better algorithm. This is a saying. That means your data is very good enough, then whatever algorithm, even though that algorithm is not good enough, still it works better. Your data is not good enough. That means it is not an actual meaning, it is not really reflecting to the true sense of that problem. Then even though how best algorithm you are applied, you cannot able to achieve the good accuracy. So what are the reasons for how can we say that your data some of you are like data sparsity. Sparse data means much of the data values are missing in your data. That means it is a sparse. So the missing data values actually cannot able to take those patterns properly because already you missed the sum of information to capture the hidden patterns in the data. So you need to be very much keen how to fill that data, or you try to avoid the sparse data and you simply take a dense data in such a way that it will work for your applications. So how to deal with this one? So one is gather the more data so that it will be less sparse, and we have to have multiple data will try to capture the correct pattern of your problem, and you could able to deal with the feature engineering. Which features are good enough to post these into the my model? As I mentioned earlier, I have not taken the serial number as a feature because that is not fit for me. Likewise, which feature is good enough for me to give it to the model? So that feature engineering is also very much required. So I am using the dimensionality reduction. Like if you have the large data, some of the algorithms may not really fit into that. Then we need to reduce the dimensionality so that we can handle that model very well. So these are additional things we need to do when the data is not proper or when we are picking up the data with these features. So this is how you can handle with the data. If the data is good enough, then the machine learning works best. Thank you. Any questions? I could not able to give more time to the Bayesian theorem as my time is already over. So any doubts? Have you understood what is meant by Bayesian tree and Bayes theorem, how it works for the classification and iteration? Yes or no? Thank you.
Thank you, ma'am. Thank you, everyone. We had the session for now. And right now, we'll be having 10 minutes break. After that, we'll continue with our next session with Dr. Ganga ma'am. So I request